This is one of those problems that is very easy to do and yet very hard to get completely correct the first time through. Let's see why that is. In order to undo the squared on the left side, we would do the square root of both sides. Yeah. So we'd do the square root of x squared equals the square root of 25. Okay, so square root of x squared is x, and square root of 25 is 5. So we'd be saying, okay, x equals 5. However, that's not entirely correct. Because what number squared equals 25? 5 and negative 5, yeah. There's actually two different answers, 5 and negative 5. Because negative 5 squared, a negative times a negative, is a positive. So negative 5 squared is also 25. So what ends up happening here is that when we take the square root of both sides of the equation, we actually get a plus or minus square root of 25. And that's actually the symbol we use. It's a plus written above a minus. That means both a positive and a negative version of that number.
So if you get your answer, it will be x.
When you write your answer, there's two different ways you can write it. You can write it like you see here, x equals 5, comma, negative 5. The comma is just meaning and. You could also write it as x equals plus or minus 5. That's perfectly fine. At the start, I'd kind of like you to be doing it this way at the start just so we can get used to seeing the two different numbers and it helps us get used to it, but both are correct. All right, so to practice this idea, we're now going to be solving a number of different equations involving x squared. So, please start by writing down these two equations. If you feel like you got the idea about how to solve them, go ahead and solve them. If not, hold tight because we'll go through them together. So, when doing these, that plus or minus part where we get the square root, we only deal with that once we have x squared equals. So the x squared has to be by itself. That's our first goal then. So as you take a look at that first one there, the very first thing I'm going to do is I'm going to add 16 to both sides. Because I'm trying to get rid of the number that's over with the x squared. I want it to be x squared equals. So then we do 65 plus 16. That is going to give us 81. Okay, so if x squared equals 81, then we take the square root of both sides. So we got the square root of x squared and the square root of 81. And so x equals 9 and negative 9. The way that we show that in our work, when you take the square root of both sides, put that plus or minus in front of that square root on the other side. So x equals 9 and negative 9 in that problem. Let's take a look at the second one. Again, I want to get the x squared by itself first, so I got to get rid of the 5. Right now, it's 5 times x squared, so I'm going to divide both sides by 5. Because I'm undoing the multiplication. So on the left side, that gives me 4. On the right side, that gives me x squared. Now that I have the x squared by itself, x squared equals, I can now do the square root of both sides. And since I'm doing the square root of both sides, I put a plus or minus on the other side from where the x squared is. And so I end up getting that x equals 2 and negative 2. So again, write down these two problems. If you feel comfortable going ahead and solving them, solve them. If not, think it through, try to figure out how you do it, but yes, we will work it out together. So when doing the first one, it can be tempting because of what we've been doing up to this point to start by expanding it out. And you end up turning it into x squared plus 10x plus 25. However, there's a problem doing this. Because you'll notice that by writing it out this way and multiplying it out and expanding it, we now have 2 x's in our equation where we used to have 1. That's not really helpful. We actually don't want to have 2 x's there. In fact, our goal is to get 1 x so that we can end up with an equation that says x equals. So rather than expanding it out, let's start this first one by getting rid of the squared. So the very first thing I'm going to do is I'm going to take the square root of both sides. And of course I end up with that plus or minus in front of, in this case, the 9. So when we do that then, we end up with a plus or minus 3 equals x plus 5. Because notice on the right side the square root got rid of the squared. That was the whole point of doing it. But notice what we have now. We have x plus 5 equals a plus or a minus 3. You actually now basically have two different problems. You have 3 equals x plus 5, and you have negative 3 equals x plus 5. We have another step to do on both of these numbers. In order to get the x by itself, I'm going to have to subtract 5 from both sides. But I'm going to have to do that on both of these equations. I got to do it separately because our answer is not just going to be a plus or minus the same number this time. On the first one, where it equaled a positive 3, we end up getting negative 2 equals x. On the second one, where it was equal to negative 3, there we get a negative 8 equals x. Now you could leave the answer looking like that, or if you'd like to just give a single line to summarize it, you'd say x equals negative 2 and negative 8. Just put the little comma between them. It shows that we're separating our answers. And then when you go to do the second problem on this page, we're going to approach it very similarly. But remember that before I can take the square root of both sides, I have to have the squared by itself. So in the case of that second one, the very first thing I want to do is get rid of the minus 7. So first thing there, add 7 to both sides. Having done that, it now looks just like the first problem we did on this page. You should know how to solve it out from there. So go ahead and finish solving that problem from that point. So now that I have the squared by itself, this is where I take the square root of both sides. So x minus 8 equals a positive or a negative 4. Now I'm going to go ahead and split that into the two equations. So x minus 8 equals 4, and x minus 8 equals a negative 4. And then for both of those, I'm going to add 8 to both sides. It looks so short at the start, and yet we end up having to do so much. So x equals 12, and x equals a positive 4. So those are our two answers, 12 and 4. Okay, next set of problems. I think you've seen enough with the previous problems that we've done to know how to approach these. So go ahead and write down and solve both of these. All right, so I'm going to go ahead and work these through here. So first up, with the first problem, we got to get rid of the 5 and we got to get rid of the 17. Since we're undoing this, I'm going to go backwards through the order of operations. Therefore, I'm starting by getting rid of the addition. So we're going to start by subtracting 17 from both sides. So that gives me 5 equals 5x squared. Then I can get rid of the 5. Right now it's 5 times the x squared, so I'm going to undo it by dividing. So we divide both sides by 5, which gives me 1 equals x squared. At this point, we can go ahead and take the square root of both sides because I have the squared isolated. So we end up taking the square root of both sides, which gives me x equals 1 and negative 1. Because the square root of 1 is 1. And of course, we got to have the plus or minus. Okay, for the second one, we got to get the squared part by itself first. The squared part is this. So then that means I got to get rid of the 3. So since it's 3 times the parentheses, I'm going to divide by 3. Now, if you're wondering, can we multiply the 3 into the parentheses? The answer is no. Because the parentheses are squared, but the 3 is not. Therefore, we can't include it. So now I have x minus 8 squared equals 100. Now I can get rid of the squared. So I take the square root of both sides. On the left side, that gives me x minus 8. On the right side, that gives me a plus or minus 10. This is the point where I split it into two equations. Now, as I split it here, you really do need to still show all of the work. It can be tempting at this point to say, yeah, but I know I'm adding 8 to both sides, so, I'm just going to add the 8 and not write it out. Well, we are at that point algebraically where we may not need to write out every step every time in order to do it accurately, but it doesn't mean that we should, because something that happens is that we forget that we're adding 8, and we actually can make the wrong move. I've actually seen it on a number of people's papers already, where we just wrote out x minus 8, and we thought I'm going to add 8, but we actually subtracted 8. By writing it out, you keep yourself from making what you might call silly mistakes. That is, you know better, but you got in a hurry and you made the mistake. By writing it out, we avoid those little things. All right, so in this set of problems, the first one, you're going to have to combine all of your algebra skills now. And the second one's going to pull in another skill that we are working on fairly recently. So in the first one, there's tons of steps, but it works out to be a nice, pretty number. In the second one, there's not a lot of steps. We add 4, we add 4. We get x squared equals 40, but when we take the square root of both sides at this point, we get x equals plus or minus root 40. Yes, we still have to have the plus or minus there. This one's not such a pretty answer. But remember that we did that work simplifying radicals, and so we can give our answer here simplified as well. So we need to simplify the root 40. So it's going to be x equals, it's still going to be plus or minus, but then I look for the biggest perfect square that goes into 40. It's just 4. And so we end up getting x equals plus or minus, the square root of 4 is 2, and root 10 stays root 10. So our final answer here is x equals plus or minus 2 root 10. And of course, yes, you could also write it as 2 root 10 and negative 2 root 10. You could write it out as two separate answers that way. 2 more problems to solve. So in that first one, we start by getting rid of the 5 out of there. Then we got the squared by itself, so now we can take the square root of both sides. And when you do that, you get x minus 2 equals plus or minus root 8. Does the square root of 8 simplify? Yeah, it does. There is a perfect square that goes into that. So I'm going to do that first. So x minus 2 equals plus or minus. I'm going to actually write out the steps here. It becomes root 4 times root 2. So x minus 2 equals plus or minus 2 root 2. But then I'm not done. In order to get the x by itself, I have to add that 2 to both sides. And this is where sometimes it can seem a little tricky. So I got x equals. Can I combine the 2 and the 2 root 2? No. The 2 from the left side does not have a square root attached to it. The 2 on the right side does have the root 2 attached to it. So I can't combine them. So instead, my answer is going to be 2 plus or minus 2 root 2. I cannot simplify it at all. The only other way you could write your answer would be to write it as 2 plus 2 root 2 and 2 minus 2 root 2. That means the same thing. This problem's an illustration of what happens when you don't get a nice, pretty answer. This is not uncommon when doing problems like this and having to solve them out. All right, then on the second one, again, we start by getting rid of the addition and subtraction first, so I add 10 to both sides. Okay, great. So 9x squared equals 16. Okay, I still need to get the x squared by itself, so I'm going to divide both sides by the 9. So I got x squared equals, and then what do we do with 16 divided by 9? You know, I don't want to mess around with the decimals. Leave it as a fraction, and in fact, you're going to see that actually makes your life a little easier here. I'm going to write it as 16 ninths. Okay, yes, it's a fraction. Sometimes it makes the heart speed up a little bit, but let's continue with our method as we know it. I got x squared equals, so I got to get rid of the squared, so let's square root both sides. So x equals plus or minus the square root of 16 ninths. This is actually pretty doable. And this is part of the reason why I bring up this particular problem, because I want you to see how to handle fractions with the square roots. If you have a square root of a fraction, you can take the square root of the top and the bottom individually. So the square root of 16 ninths is going to be the square root of 16 over the square root of 9. Square root of 16 is 4. Square root of 9 is 3. That's why I like to stick with the fractions here. If you were doing this on your calculator and dealing with decimals, you'd end up with some ugly looking decimal. You'd still never realize that this was something you even could have just done in your head. So I just want you to be able to see this for the times when you can do it nicely. These are the last problems we're going to be doing together here. Again, a little bit of a new wrinkle. So in the case of the first one there, the first thing we got to do is we got to move that 9 out of there, so we got the x squared by itself. So we got negative 4 equals x squared. The answer here is not 2 and negative 2. Because what's 2 squared? 4. It's not negative 4, it's 4. What's negative 4 squared? I'm sorry, what's negative 2 squared? Also positive 4. It is impossible to square a real number and get a negative solution. Therefore, we are going to say no real solution here. So you'll notice that if you get x squared equals a negative, that means there's no real solution. Now, you'll notice I'm specific here. I say there's no real solution. In the near future, we're going to be seeing what happens if there's non-real solutions, and we'll actually be taking a look at some of that kind of stuff. But for now, we can just say no real solution. Having done that one, finish up the second one if you haven't already. So when doing the second one, again, we get rid of the addition and subtraction first. So in this case, subtract 9. So we get 0 equals 4 parentheses x plus 2 squared. And again, I divide both sides by 4. 0 divided by 4 is 0. So 0 equals x plus 2 squared. And then we look at taking the square root of both sides. Can we take the square root of 0? Yes. The square root of 0, though, is 0. This is not a plus or minus 0, because positive 0 and negative 0 would be the same thing. 0 does not have a sign. So we end up with 0 equals x plus 2. So at this point, in order to figure out what x is, I subtract 2 from both sides. So negative 2 equals x, and that's it.
Negative 2 is the only answer?
So in this case, there's only one solution. This is how you get exactly one solution out of this. If at some point you have to take the square root of 0, you can end up with one solution. Otherwise, square root of a positive will give you two solutions every time.